Alright guys, so this is going to be our last video on identities. So I'm going to work through two different types of identity problems today, conjugates and factoring. So you might remember conjugates from when you were dealing with radicals. So for example, total side note, if you had like something like this, you couldn't leave a square root in the bottom, so you multiplied by the conjugate, which was 1 minus root 3 on the top and bottom. We're going to use a similar idea here. Okay, so when we look at this first example, um, I actually, for once, am going to deal with the right-hand side. Okay, you could deal with the left-hand side, and I can show you both ways, but I'm going to show you dealing with the right-hand side. So I'm going to start with sine theta over 1 plus cosine theta. So the conjugate of that would be 1 minus cosine theta on top and bottom. So from here, I am going to actually leave the top alone. I'm not going to distribute that sign in yet. You're going to see what's going to happen here in a second. I am, however, going to FOIL this bottom together. I would get 1, and then minus cosine theta plus cosine theta, and then minus cosine squared theta. Well, remember from our chart yesterday, 1 minus cosine squared theta is the same, sorry, can't write fast enough, as sine squared theta. I know I'm not going vertically. It's because I want to show you how to do it two ways, so I want room for both. You should definitely keep doing these vertically, sorry. Okay, so now let's reduce this. I have a sine on top and a sine squared on the bottom, so that leaves me with just one sine on the bottom. And then I'm done. My goal was to get to this side. So let me show you could do it similarly with working with the left-hand side. So this is option 1 and this is option 2. You don't have to do it both ways. I'm just showing you how there's more than one way to do it. So this way, my conjugate would be 1. Now, total side note, you're used to using a conjugate because of stuff you can't have in the denominator. Here, it doesn't matter if it's in the numerator or denominator. So here, my conjugate would be 1 plus cosine theta. Clearly, you can't get a conjugate of just a single piece. Now, when I FOIL that top together, just like above, I get 1 minus cosine squared theta. The bottom I'm going to leave alone for right now. And you can see that top is sine squared theta. It's just kind of like above, but like in reverse. And then those reduce, and you got to the right-hand side. So you could really do it either way. It's kind of a preference thing. Okay, let's take a look at another one. So in this one, I actually, once again, worked with the right-hand side. I actually have this done two different ways. Actually, you know what? I'm going to work with the left-hand side. I like that way better. So I'm going to multiply by the conjugate here, which would be 1 plus sine theta. Oops. Okay, so, sorry, my screen's frozen. Okay, so FOIL the bottom together and you would get 1 minus sine squared theta. If you look at your chart, 1 minus sine squared theta, that denominator is the same as cosine squared theta. You reduce those, you're left with a 1 plus sine theta over cosine theta. Well, let's look. What's our end goal? So our end goal is 1 over secant minus tan. So from here, if I split this, you're like, oh, that's secant theta, and that's tan theta, but shoot. Now, I will say this, and I kind of went down this road so you could see what's going to happen here. It's going to be hard to get from here to here. I'm not saying it can't be done, but it is going to be a little bit harder. But we could totally do it. So if we multiply by the conjugate here, like throwing this over 1, it's not that much harder. Okay, when you FOIL that top together, you're going to get secant theta squared. Then you get a minus secant tan, and then a plus secant tan, and then a minus tan squared theta, and then you'll get this on the bottom. and that top, sorry, I'm kind of out of room, that's equal to 1. So it's not that much harder. So that's one way. I'll show you the other way. So I started with the left-hand side. Here I'm going to start with the right-hand side. Just once again to show you different ways. So here the conjugate would be secant theta plus, plus tan theta. So my numerator secant plus tan, denominator is secant squared minus tan squared. And then this kind of picks up, whoops, nope, that's right, sorry. That kind of picks up at the same place this one picks up from here. You could do another conjugate from there. Okay. Oh no, sorry, I'm being silly. Sorry. My end goal is to get to the left-hand side. My bad. Sorry. So from here then, I split this into, I made this 1 over cosine theta, secant's the same as 1 over cosine, and I made this into sine over cosine. So then I said, ooh, if I combine those, I have, because they have a common denominator already, I have 1 plus sine over cosine. Shoot, we're getting closer. We now have sines and cosines. So now let's multiply by the conjugate, which is 1 minus sine theta over 1 minus sine theta. So up top, I get 1 minus sine squared theta. Sorry, guys, I have this written in my notes a couple different ways, get all mixed up here. Once again, running out of room. 1 minus sine squared theta is cosine squared theta. And then I can reduce one of those cosines, and I'm there. So they're both kind of long, okay? And it's not like one's any better than the other. It's kind of up to you which route you want to go. All right, let's do a couple with factoring. Okay, so I'm going to work with the left-hand side here. So if I factor this and kind of think back to, I think there was a problem like this when we did the algebra review. This would factor to x squared minus y squared and then x squared plus y squared. So let's use that similar idea. Secant squared, my gosh, plus tan squared and secant squared minus tan squared. Well, secant squared minus tan squared is 1, so we're done. All right, let's look at another one. So in this one, I am going to work with the left-hand side again. So when I look at this, I'm like, ooh, I have a GCF that I could factor out. So let's factor tan squared out. So what's left is secant squared theta minus tan squared theta. Ooh, and that's 1. So I have tan squared theta, and I somehow have to get that to stuff with cosine it. So let's rewrite this in terms of sines and cosines. So tan squared would be the same as sine squared over cosine squared. So I have the denominator. Ooh, sine squared is the same as 1 minus cosine squared. So it's all about that chart and using things that are equivalent in that chart. Let's do one more. All right, I'm going to work with the left-hand side again. Look at this. This factors. And think about it if you had something like this. Oops. Sorry, guys. If you had something like this, oh my goodness. Right? Something like this would factor to x squared plus y squared and x squared plus y squared. X to the 4th plus x squared y squared plus x squared y squared gets you the 2x squared y squared in the middle, and then plus y to the 4th. So similar idea here. Sine squared plus cosine squared, and sine squared plus cosine squared. Well, hopefully you're like, well, they're both 1. So I have 1, and I need to get to this. This is one of those ones that you have to look at that chart. Oh, well, 1 is equal to cosecant squared theta minus cotan squared theta. Done. Okay, so you're going to have some practice on this. Please reach out if you have any questions or need any help.